Okay, so good afternoon, everyone. I am Abdul Subhan on behalf of Hackslash and GDSC. I'll be taking today's session of machine learning, which is termed as ML Quest, Pitchtember. So let's begin. So let's unleash the potential of machine learning. All right. So today in this presentation, we will be exploring the impact of machine learning and how it has impacted today's generation. So let me just get on with it. So let's divide the words machine and learning. So there can be two interpretations of machine learning. You can talk about learning from the machines or making the machine learn. However, it might seem that we're talking about learning from the machines, but in fact, we're talking about making the machine learn. Now, what happens is when you're trying to feed in some data to the machine, you're trying to extract some information from the machine, and you want the machine to automate itself and just get on and give some predictions. So, this is how machine learning works. Okay, moving on to the next slide. We will be talking about some of the fundamentals of machine learning today. We will be talking about few algorithms as well. And also, we will be talking about the differences between traditional programming and machine learning, which is going to be a very interesting session today. And yes, later on in the later half of the session, we will be coding it up as well. So, yeah, let's move on to the next slide. Okay, so this is a very good representation. So, uh, talking about the differences between traditional programming and machine learning. Okay. So in the first half of the page, we can see that we're talking about traditional programming. So as you can see, we're feeding the computer with data and program and getting the output. That's what happens in traditional programming. And I'm sure you guys must have heard about traditional programming as you guys have already attended the sessions of C++. So that is basically traditional programming. You feed in the data with the computer and then you have a certain program which will then produce a certain output. But now talking about machine learning, the interesting part is that it is a bit different. You actually feed the machine with the data and you actually feed the output as well. And then we get the program. So what happens is the machine learns from the data it gets and also from the output it predicts. So we can talk about when we're feeding the machine learning model, we get to know that when we're feeding it with some data set, we are already training it with some predefined input data as well as the output it has produced. So we're talking about historical data. So, for example, I'll take a very basic example. We're talking about temperature of today. We can talk about the intensity of clouds, and we can talk about the intensity of sun, and then we get to know whether it is going to rain today or not. So, let's take for example, today's temperature was 23 degrees Celsius. It was a bit sunny, it was a bit cloudy, and on that day it rained. And we can talk about some other day as well where you notice that the temperature was a bit higher, the sun was a bit too bright, and it did not rain. So then the machine will now understand, okay, on this trend, it was then when it rained. So this is a basic idea of machine learning, and this is how I learned, in fact, whereas you're not learning from the machine, you're actually making the machine learn. So let's move on to the next slide. Uh, Basically what comprises of a ML model. So what is an ML model? Basically, it is the actual architecture which gives you the predictions. So you have the data, you have the basic algorithm on which it is some sort of a mathematical function. It then tries to understand it, then generates some patterns, and it understands. The machine slowly and steadily starts to learn, and then both of it now comprises of the entire ML model. So let's talk about a few examples, or you can say the applications of machine learning. So in the finance sector, we can, detect fraudulent activities. You can definitely, automate the trading strategies as well. And obviously, very importantly, we are personalizing customer experiences. So altogether, this is helping the entire industry, whether it is the customer or we can talk about the company owners. Spam detection is one of the very important applications of machine learning. Now, when we're talking about healthcare, now this is another domain where um, the machine learning is quite efficient in, which is healthcare. So it enables the patients to get some personalized treatment plans. We have disease detection beforehand, basically, and medical image analysis. So with this. what happens is, the patient outcomes, it improves, and then the healthcare industry together, grows as such. So not only these two things are the applications. I've just kept it short. We have many more you know applications of machine learning. You guys can definitely check that out. Now let's get on to this steps in machine learning. So now you will be getting some idea about what happens in machine learning. So I'll just brief down the steps. So first of all, we have data collection, we have data preparation, we have choosing the ML model. We can then train the model, we can evaluate the model, and then make predictions. So now I'll start to brief out each and every step. So first of all, we'll be talking about data collection. So before any machine learning model prediction, we're trying to solve some use case. What we do is, first of all, we collect data. Now, when we're usually solving some machine learning problems, um, there are many sources of data. Usually, when we're already solving problems, we get the data sets available on Kaggle or some sort of other websites. But just imagine you don't have any data predefined or uh, any as such. So what you do is you start to collect data on your own. You just maybe release out Google Forms or surveys and all that stuff. That is where the data collection happens. And before any problem statement of machine learning, the most important part is data collection. Because if you feel like your data is accurate, you have enough amount of data, it is then when your machine will start to learn properly, and it is then when it knows what to give predictions from and what to learn. We just talk about the human brain. For example, you're a small child, you have no idea about anything, and you just show that small child, yeah, this is a yellow ball, this is a ball, this is a triangle, and all that. Initially, it might not know, but when you're feeding it with some sufficient amount of data, it is then when your, you know, the human brain, it starts to learn. And basically, machine learning completely revolves around data. So when you're getting into machine learning, just know you're going to play around with lots of data. Moving on to the next step, we have data preparation. So now just assume you've got the data, you have some sufficient amount of data. Now what you're going to do is prepare the data. अब आपके पास data आ चुका है. Now what you have to do is figure things out with that data. It is very important for the data to be accurate. Now, for example, you might be filling out some Google form, okay, which has entries. So now, just for example, you have a very important field, and that person, he just completely enters the data in wrong format, or maybe he just skips it. So this is where the data gets inaccurate, and then your machine learning model won't be able to give you exactly amazing predictions. So it is very important for the data to be aligned with your problem statement. It has to have a proper format, should not have null values. We will be talking about this later on as well. Now moving on to the next step, we have which is choosing your machine learning model. Um Now we will be talking about the various machine learning models, like some of them, and when we will be coding it up as well, I'll let you guys know about it. Now training the machine learning model, choosing the machine learning model. So not every problem statement will be solved by a certain model. We have different models for different problem statements. For example, you have to predict the house, uh, predict the price of a particular house in California, maybe. So you will have to choose a machine learning model that gives you continuous outputs, right? So just for example, for that sort of problem statement, we will be taking linear regression maybe. And for example, now you have to predict whether um, the particular flower based on its petal size and all that, we will be coding it up as well. So that is a classification problem. So where you're classifying things. Now training the model. Now once you've chosen the machine learning model, you will be training the machine learning model, because obviously, how will a model give you predictions when it is not trained? So then you will have to feed in the machine learning model with the amount of data that you have, is then when the model will start to learn from it. So this is the phase of training the model, and then you have evaluating the model. Now, definitely after you're done training the model, choosing the machine learning model, you have to evaluate the model, right? You have certain set of test data which you will be testing the model with. and you will definitely get to know whether your model is predicting uh, you know whether the predictions are accurate or not, because obviously you cannot work on a model which is not quite accurate enough. So we can take into account the accuracy of the machine learning model. And then the last step is definitely making predictions. Now, um, you've you've trained the model. Now what for? You definitely want to get predictions out of it. So the last step is going to be that you make predictions and you finally get to know what your machine learning model has learned from and what it is predicting. So this was completely about all the steps in machine learning. So now we will be talking about types of machine learning. If we go on to the next slide, you have certain types of machine learning. You have supervised learning, you have unsupervised learning, and reinforcement learning. In this session, we will be talking about supervised and unsupervised learning. And yes, this there will be a follow-up session tomorrow, which is going to be around deep learning. So you guys should join tomorrow as well. This is going to be a continuation. So let's move on. We will be talking about supervised learning. So first of all, let me just brief you with some terms: regression, classification. If you guys remember, I had mentioned about continuous data. I had talked about house price prediction, where you have to predict the you know the output as a continuous value. It is then when it is termed as regression problem. And I also talked about flower species. It was about classification. So you're classifying the data, you're grouping them, and regression is definitely the continuous data. So basically, let me just read this out for you guys. Supervised learning is the type of machine learning in which machines are trained using well labeled training data. Now, what we're talking about labeled data. So, in supervised learning, basically the machine learning model knows what the input is and knows what the output is. We will be talking about the demonstration of it in the next slide. So, yes, as I told you guys about regression and classification, it is very well mentioned on the slide. So let me just demonstrate you the supervised learning. So you have labeled data, which is you can in front of you, you can see the shapes, right? And you have the labels. So in labels, you are given that it is a hexagon, it is a square, it is a triangle, and then you have the labeled data itself. As you can see, it is pretty much visible over here. These are the labels, and this is the labeled data. And then we go through the model training process, we get predictions. So as I talked about test data, we are evaluating the model, right? So when we're testing with this and then predicts whether it is a square or a triangle. This was an example of supervised learning where you have the labels and you have the labeled data as well. And then it later on predicts that yes, this so basically your machine learning model has learned whether it is a hexagon, it is a square, it is a triangle. So when you're next up, when you're feeding it with some test data, so you can see this is a square and this is a triangle, the model is very much able to differentiate between them, that okay, yeah, this is a square and this is a triangle. Talking about unsupervised learning, so let me just straight up get to this image. Okay, you have unlabeled data. So you have cat and you have a dog. Basically, we as humans, we know that this is a cat and dog. Why? Because we have been told since our childhood, yeah, this looks like a dog, this looks like a cat. Now, the machine learning model is completely a baby. It doesn't know what is a cat and what is a dog. So in unsupervised learning, what happens is that the machine learning model, it itself tries to learn from the unlabeled data. So let me just read this out for you guys. As the name suggests, unsupervised learning is a machine learning technique in which models are not supervised. They don't have labels in the training data set. There are completely no labels. Instead, what models do is that they itself they find the hidden patterns and insight from the given data. So when you can talk about the unlabeled data, see the what the machine learning model does is that from the unlabeled data, it is trying to find out patterns from it and learn. So when the machine learning model from the input raw data, it itself finds out patterns, it is able to identify whether this is a dog or a cat. So what is happening is that there is an unlabeled data. Your machine learning model is quite proficient enough to detect patterns in the training phase, and then it is able to, just give you the output, and it is trying to group it up. It can be compared to, the learning which takes place in the human brain. So we don't know whether this is a dog or a cat when we are grouping things. We just try to find out patterns. Okay, this has this sort of fur, this has this sort of eyes, and all of that, and then we try to group it up. This is basically unsupervised learning. Now, talking about what we will be coding up, we will be talking about classification problem. I just want to keep it very simple for you guys. So we will be talking about classification. Let me just brief it up for you guys, and then we will be moving on to the coding part. So now we have independent input variables. Now, when we're talking about the data, when you're feeding the machine learning model with some sort of data, it has a dependent feature, it has an independent feature. We will be talking about all of it as we move on. So now what has happened in the classification problem statement is that there were independent input variables, and then the model was able to categorize it into vegetables or groceries. So this is how it works. The classification, the grouping happens based on the similarities, and then it is grouped onto the various classes or various groups you can talk about. So this was just a basic idea about it. So we will now get on to the coding part. So this is just a very basic snippet of the code. You will um, I'll try to explain the code to you guys. So for the coding part, what we're going to do is that first of all, I want you guys to open Google Colab. So just go on to Google and search at Google Colab. Now, I'm not going to go to the exact basics of Python. I'm going to be explaining it as we move forward. There's obviously the basic prerequisite of machine learning is to um, you know uh, just have a good knowledge or good control over Python. Python is definitely a very basic and very understandable language, so you guys won't be having much issues learning that. So let's just move on to so you guys can open this link and then you can click on new notebook and this thing will just pop up on your screen. So first of all, what you're gonna do, this is your IDE, this is your collab notebook, this is where we will be coding. So we can just connect to runtime. So now it is now connected to a runtime, so which will help us to you know run the code and definitely train our machine learning model and get predictions. So we're initializing. Okay, now we're connected to the Python 3 Google Compute Engine backend. So basically, this collab is provided by Google. So you guys can definitely use this. You guys can use Jupyter Notebook as well, or maybe some sort of local IDs like VS Code or. But actually, Google Colab is very fast and it is very efficient in running the code very fast. And you can see this data over here. You have RAM in your disk. This is very um, actually good for you guys. So, okay, now we will be talking about certain things. So let's just import a few things. Now you want to, when you're trying to import your model or you're trying to have some mathematical functions, what you're going to do is definitely take use of the vast libraries that Python offers. So I'll just import, okay, let me just write this down and then I'll explain it to you guys. Okay, so we're talking about pandas and we're talking about NumPy. The detailed explanation of this can be definitely found on the Python documentation. So I'll just recommend you guys to read out the documentations of pandas and NumPy. So for now, just know that this is a numerical Python. Okay, NumPy is numerical Python. It helps you take on mathematical expressions or mathematical, the operations on your data set. So and pandas is used for just let me just brief it down. It is going to be used to create the data set and all some operations related to data. So we have what we've done is we've imported the pandas and NumPy as PD and NP. So basically, when we are loading this as PD, we don't have to write pandas everywhere when we are trying to use its functions. We just have to write PD and we have to write NumPy as just NP. So which will definitely simplify the process. So basically, Python is very much as English. So you just write it down as import pandas as PD and pandas have been imported. Now what we're gonna do is import cborn, just importing cborn as SNS. So again, we've imported the cborn library as SNS. So Seaborn is a library which is used for data visualization and as well as the fact that it has some data sets as well. So today when we're going to be talking about some data set, we are going to be importing it from the Seaborn library. So let me just load the data set for you guys. So we will be creating a variable named df, which means the data frame, the data set. Okay. So df is equals to sns dot load underscore data set. So basically, what is happening here is that we've imported the Seaborn library, right? हम लोग ने Seaborn library को import कर लिया and now we are taking use of its function load data set जिसमें एक function है तो कि हम लोग इसमें जो भी हम लोग को data set का नाम पता है we can हम लोग यहाँ पे इसका नाम डाल सकते हैं data set will be loaded. So we're going to be incorporating the iris data set. So let me just run this line. So for the ease of running, we just you can just press shift and enter. So the cell entirely runs. So we have imported the data set. So let me just show you guys the data set. Let me just df.head. So what df.head does is that it loads the top five data that we are going to be that is present in the data set currently. So as you can see, this is our data set that we'll be working on with. We have sepal length, we have sepal width, we have petal length and petal width. Okay, so these are basically the independent features on which the model is going to be trained, and we have this species column which is the dependent column. So what is going to happen is that based on these four values, uh, the model is going to predict the species of the species of the flower. Okay, so we're talking about sepals and we're talking about petals. So I hope you guys are aware of it. We're going to be dealing with the lengths and widths of the sepals and petals. So there are a few functions that I'm going to introduce you guys with df.info. So what df.info does is that we're going to be talking about some basic information regarding the dataset. Let me just zoom in for you guys. So we have the sepal length, we have 150 non-null values. So basically, this is a very small data set we're going to be dealing with just for the simplification of it. So the data type of the sepal length column is float 64. And similarly, you can talk about sepal width, which is again float 64 and all of that. And we have species, which is 150 non-null values with object. So basically, it's a string. You can talk about it. We have some more functions we're going to be uh, dealing with. We have df.describe. So in this, you can just look about some numerical data about the various columns. We have count, which means the number of data present in each column. We have the mean. So basically you can just infer from it. So basically this all of this process is known as data analysis. So what you're doing is you're dealing with data. You are just trying to get the hold of it. What is the mean? We have the standard deviation, we have the minimum, we have the interquartile ranges, and you have the maximum value. So you can understand, yeah, that the maximum sepal length of a flower in this data set is 7.8. So let me just move on. Now we're going to be talking about, as I had mentioned, the data preparation is a very important process. We have to get an idea whether we have some null values, because if we have null values in the data set, it is going to hinder the training process. So let me just use this function. I'll be explaining this to you guys. So df dot is null dot sum. So what we're going to do is we're checking the null values per column and we're summing it up. So with this function, we're getting to know that none of the columns have a null value in them, which is actually a brilliant thing. We don't have to handle null values. When you're going to be advancing in machine learning, you will be learning about handling null values, which is definitely not the agenda for today's session. But yeah, as you progress in the world of machine learning, you guys will be knowing about it. Okay, now we've talked about the various categories the species column has. So let me just use this command. So we have df of species dot unique. So what we're gonna do is here we're getting to know about the unique values in the output column. So basically we can infer that we have three um, species we're gonna be classifying them into. We have a setosa flower, we have a versicolor flower, and we have a virginica flower. So now let's just move on to okay, so now let's just do one thing. I'll just simplify this process for you guys. Instead of a multi-class classification, today let's just deal with a binary class classification. So what I'll do is I'll just drop this setosa the setosa rows. So we just have to classify whether it is a versicolor or a virginica. The only reason I'm doing this is because I want to simplify this process for you guys. So let me just run this command and then I'll be explaining it to you guys. Species not equal to setosa. Yeah. So let me just uh, df of species dot unique. So now we have actually no, not really. We just have to assign df. over here and can run the code now. So yeah, now we just have versicolor and virginica. Now let's talk about this line of code we've dealt with. So I'll just break it down a bit for you guys. Let me just insert a new code over here. Uh, in fact, I'll just drag it down a bit. So the first portion of the code is that df of species not equal to setosa. So let me just run this separately for you guys. Yeah. So what it does is basically it returns you the Boolean values. Now it is returning you the Boolean values where the species column is not equal to setosa. So the true values indicate that over here we don't have any species data which is setosa. And then when we are assigning it to this, when we are enclosing it within these square brackets, we are now getting the entire data set, which is consisting of the species which do not include setosa, and we are then assigning it to the data frame which we had initially created. Now we just have species and just two species, which is versicolor and virginica. Okay, now I had talked about dependent and independent features, right? So let me just talk about. Okay, we have the independent features which are going to be sepal length, sepal width, petal length, and petal width. And species is going to be our output, which is y. So basically, in mathematics as well, the input, or we can say the function, it depends on the x, right? So y is going to be our output, and x is going to be our independent features. So what we're going to do is we're going to divide the data set into independent and dependent features. So first of all, we will be assigning the output as species. So let me just do this first. We're gonna have df of species as the output feature. Okay, now we have just this. Let me just show you guys. Y dot head is a function where you can display the top five values. So you can see we're just getting the species column, which is going to be used for the output. Now we're talking about x. So what we're gonna do is let me just write it down first, and then I'll be explaining it to you guys. I would highly recommend you guys to just learn basic Python, which is required for machine learning. Um, so what we've done is we've assigned the independent features to x. What we've done is from the data frame, we have dropped the species column axis equal to 1. Axis equal to 1 basically is basically the column. So to the independent feature x, we've assigned the data frame other than the species column, because definitely our species column is an output feature, and for the training part we need these independent features on the basis which it is going to predict. Now, we will be using the sklearn library to, you know, um, just make some model and make some predictions. So first of all, let me just import few things. Linear underscore model. Import logistic regression. So I had talked about a classification problem. So basically this is a classification problem. So what we're gonna do is basically we're gonna use this logistic regression part, and for that what we have to do is when we are dealing with data, you just have one data frame, right? But what we're gonna do is that we're gonna deal with training data, and we're gonna deal with test data. Training data is used for training the data, and definitely, as the name suggests, test data is used for testing the data. So let me just divide this data set. For that, we're going to be using, so let me just run this cell. So basically what we've done is we've imported this logistic regression model, which is pre-built in Python. So now what we're going to do is that from sklearn, which is a library with its function model underscore selection, we're going to be importing train, test, split. So what train test set does is that it divides your data set into training and testing. So definitely we have X and we have Y. So we're now going to be dividing into train and test of X and train and test of Y. So what we're going to do is X underscore train, comma, X underscore test, comma, Y underscore train, Y underscore test is equal to train underscore test underscore split. So this is basically a function. We can just term it as a function. Now we're going to be assigning the values which this function returns into x train, x test, y train, and y test. The parameters are the x, the independent features data frame we had created over here. Uh, where is it? Yeah, this one, and y we have here. And we're going to be talking about random state, which is something not very important. We're going to be not going to be discussing about it. And we have the test size. We can discuss about test size. What test size does is that For the test data, it is going to, assign 25% of the data set into test. It depends on various problems. You have data engineers who are going to be telling you about this, like what amount of data you need to keep for testing and what amount of data you need to keep for training. Now what we're going to do, we've just imported this logistic regression model, right? So what we're going to do is now we're going to just create an instance of this model, which is logistic regression, and we're gonna keep it as it is. When you're gonna be learning about oops in Python, you're gonna know what is about instance and all of that. So basically, in layman terms, what I've done is I've imported this logistic regression model and I've created an instance which is okay. Just let me just simplify. We're just gonna be using the logistic regression model with this variable now. Now we've talked about X train, right? Let me just show you guys the X train. This is how our train data set is looking, and this is how our Y train is looking. Yeah. So basically this is definitely aligned. You can see 65, 65, these are the index values. So now we're going to do is model.fit. So now you're training the model. Yeah, you're training the model with the train data. So as I had talked about the training process, we use the model in the model we fit it with the training and training data set of X and Y. So now the model knows. Now the model definitely knows corresponding to what sort of sepal length, sepal width, petal length, petal width, what sort of output is it? Is it a versicolor flower or is it a virginica flower? Now, we've fitted the model, and now what we're gonna do is, we're gonna be talking about the predictions. Now, I'm just gonna assign a y underscore pred variable, which is going to be storing the predictions. Now, we talked about testing data. So now this is where the testing data is going to come in place. So we're using the model dot predict. So all of the models, they have this function dot predict because obviously we have a model and we have to predict from it. So now we're going to be storing the predictions of the test data. The testing data is now fed into the model, which is now it's not actually fed into the model. Now the model is now trained. So now it has to make predictions based on the excess data. Now the model knows that it has some data. Now it will start to recognize some past trends, and then it will predict the data. So before we move on to making some predictions, I'll be making some predictions as well. Now I'm just gonna check some metric. I had talked about in the PowerPoint about uh, evaluating the model. So we definitely have to know how well our model is performing. So we're going to be talking about accuracy of a model. So from sklearn dot model, sklearn dot metrics, as the name suggests. From the sklearn library, we're getting the metrics, and we're importing accuracy underscore score. So from this library, from this function, we're importing this accuracy score, which will now help us to get to know about the about how well our model is performing with respect to the predictions and the y-test. So basically, y-test was the data which was corresponded to x-test, and then we had to make predictions. And now we've got to know about what is with respect to the y underscore pred. So I'm gonna print. So basically, print statement is used to print anything. So if I just print high, it's gonna print high. Yeah, so it basically prints high. This was just a demonstration of the print function in Python. We're going to be talking about the accuracy score. So we've definitely loaded the accuracy score. And what we're going to do is we're testing the model with y underscore pred and y underscore test. Okay. So we're going to be knowing about the accuracy of this model, which is 92, which is 0.92 on a scale of 0 to 1. So basically the model is 92% accurate, which is definitely a very good accuracy when you're talking about model. Basically, this was just a binary classification statement. So it is definitely predicting 92% of the values of the data very nicely, which is actually good for a model. Okay. So now we're gonna be testing it with some custom data, which I'm gonna provide it. So we have sepal length, sepal width, petal length, and petal width. This is gonna be a little custom. So what I'm gonna do is again I'm gonna model.predict function. So basically, this is a 1D array. Let me just show you guys 1D array or a list in Python. This is a 1D array and this is a 2D array. Basically, a data frame, you can term it as a 2D array. So the model requires the input of this form of two square brackets. So when we're feeding the model with our own custom data, we're gonna be enclosing it in um, double square brackets. So let me just input just some custom data. Let's assume that okay, let me just see sepal length, sepal width, petal length, and petal width. So sepal length was 1.2, sepal width is 2.3, and what we have petal length, petal width, which is just 4.5 and 5.6, just random data, and we're gonna get the prediction from the model, and our model is able to predict that it is a Virginica flower. So you can play around this, this notebook and this model and all of this data. So what I'm going to do is later on after the session is done, I'm going to be uploading this collab link. So if you guys want to learn more about or just play around with this, you guys can definitely do. This was just a very basic example about, um, how everything works. So you have lots of machine learning models which you can play around with. You have there is just much more to learn about machine learning, and I hope this session was very much informative for you guys. And I hope in some of you it has sparked the urge to learn machine learning. And trust me, this is a very interesting domain in today's world, because playing around with data is what has become today's need. And I think with this, we are going to be concluding today's session. So yes, this was it from our side. I, on behalf of Hackslash and GDSC and NIT Patna, we signing off, and I hope you guys enjoyed this session, and I hope this was a learning curve for you guys. Feel free to ask any questions if you've got in the comment section down below, and do feel free to suggest, and definitely I'll be providing the collab link. So that's it from my side. Thank you so much, guys.